Now one more question. Second, this dragging force or the Stokes force F depends on coefficient of viscosity neta, velocity, and the radius of a body which is falling under viscous fluid. So, and the proportionality constant is K is given as 6 pi. So again here we will have we don't know this F is proportional to neta is for, let us say this time x, then proportional to velocity power y, and then r is power z. Now the required relation will be F equals to some proportionality constant K, neta to the power x, v is power y, and r is for z. Again the same step we have to follow, giving dimensions both sides. Giving dimensions both sides. Again here, to know the dimension formula for all physical quantities is very, very important. Unless you know the dimension formula, you will not be able to solve this question. So practice it again and again and try to solve, then you will get all the questions correctly. So here force dimension is, अब देखिए बार बार आ रहा है, force क्या है, याद हो जाता है, तो इसे प्रैक्टिस करें. So this is m1 L1 T minus 2, then equal to proportional constant dimensionless, then neta. क्या होता है dimensional viscosity coefficient? Viscosity coefficient is force per unit area per unit velocity gradient. तो उससे वैल्यू आ गई इसकी m1 L minus 1 T minus 1 and the power is x. Then the velocity किया था अभी आपने m0 L1 T minus 1 is for y and r तो length है ही, so that is m0 L1 T0 to the power z. So here multiplying you will get m raised to power x, L raised to power minus x, T raised to power minus x. Here it will be m raised to power 0, L raised to power y, T raised to power minus y. यहाँ कितना आएगा? Yes, m raised to power 0, L raised to power yes z, मल्टीप्लाई करना है. अब इसमें क्या करेंगे? मल्टीप्लाई करेंगे, ऐड करेंगे. नाउ वी विल ऐड देम. सो यहाँ पर हो गया m raised to power x plus 0 plus 0, तो x plus x रहेगा. L raised to power minus x plus y, minus x plus y and then plus z, and then t is minus x minus y and t is 0 here. So here this is, and here we get m1 L1 T minus 2. So according to law of homogeneity, according to law of homogeneity, this m compare power is 1, here it is equals to x, so that means x equals to 1. Now this L we get here 1 equals to minus x plus y plus z, minus x plus y plus z, and x is 1, so this 1 comes over here, so that way you get y plus z equals to 2. So for this timing we will leave it here. Now we will compare this t. So this t power is here minus 2 and here it is minus x minus y. So minus 2 equals to minus x minus y, and the value of x is 1. So you can have minus 2 equals to minus 1 minus y. This y comes here, minus 1 plus 2, that equals 1. So y equals to 1 होता है. Now putting this value of y in this equation, we get 1 plus z equals to 2. So z equals to 1. So we have got x equals to 1, y equals to 1 and z equals to 1. So required relation Therefore, required relation will be F equals to K neta power 1, V power 1, R power 1. That means F equals to K neta R V. This is the relation. If K is not given to you, then your answer will get finished over here. And since we are given K equals to 6 pi, then we have to write one more step, that is 6 pi neta RV. This is the answer. तो एक बार फिर से देखेंगे कि we have to establish the relationship between this dragging force, that is the slope force, viscous force, which is depending on the viscosity coefficient, velocity and the radius of the body object. So let us say F is proportional to neta power x, F is proportional to velocity power y, and F is proportional to radius power z. So therefore the required relation will be F equals to some proportionality constant k neta to the power x, velocity to the power y, and r is power z. Now giving dimensions both sides, the dimensions of the force is m1 l1 t minus 2. Then k is dimensionless. The dimensional formula for neta is m1 l minus 1 t minus 1 whole power x. The dimensional formula for the velocity is m0 l1 t minus 1 whole power is y, and the radius is opposite length m0 l1 t0 whole power z. Then you have to multiply the powers, so it is m raised power 1 into x, l raised power minus 1 into x is minus x, and t raised power minus 1 into x is minus x. Here again you have to multiply it, so m power 0, then it will be l power y, and it is minus 1 into y, that is t raised power minus y. And here it is m raised power 0, z into 0, 0, 1 into z, that is l raised power z, and t raised power again 0. Now they are being multiplied, so you have to add the powers. So here m raised power x plus 0 plus 0, that is x, then l raised power minus x plus y plus z. So minus x plus y plus z, and here t raised power minus x and minus y. Now according to law of homogeneity, this is equal to this only when the bases are same and the powers are also same. So comparing m, you will get left hand side 1 and right hand side x is only there, so x equal to 1. Then comparing L, we get the L1, here it is minus x plus y plus z. So 1 equal to minus x plus y plus z. Putting the value of x as minus 1, so this comes over here, this becomes 2. So there y plus z equals 2. Now we leave it over here. Now we compare the t. So minus 2 equals to minus x minus y. Here the t is power minus 1 left hand side, and right hand side is minus x minus y. So minus 2, and the putting the value of x is 1, the minus 1 minus y comes over here. So it is minus 1 plus 2, that is 1. So y comes equal to 1. Now this value of y putting here, will get 1 plus z is equal to 2. That is 1 plus z is equal to 2. So z is equal to 1. So we are getting the value of x as 1, y as 1, z as 1. Therefore required relation F will become k neta power 1, velocity power 1, and radius power 1. So we can write F equal to k neta RV. The answer will be finished over here if the value of k is not given to you. But if it is given to you, then one more step you have to write. Since k equals 6 pi, therefore required relation is 6 pi neta RV. This way you have to do all the questions, and step by step you just do it. Now we can find third question, the relationship between the rate of flow of liquid, that is volume per second, depends on neta, depends on the radius of the pipe, and depends on the pressure gradient P by L. And this proportional constant is pi by 8. Again the question is the rate of flow, that means volume per second, depending through the pipes, is depending on the viscosity of the fluid, liquid, and the radius of the pipes and the pressure gradient. So let's say V is proportional to neta power x, proportional to R to power y, and proportional to pressure gradient power z. Therefore, required relation will be V equals to neta power x r power y p raised power l power z. Now giving dimensions, same steps you have to follow. Step by step you keep on going, you will get the result. Exactly. Giving dimensions both the sides. Very simple. This is volume per second. So dimension volume is m0, l cube and t0, but per second. So it is t minus 1 equals to proportionality constant k is there. It is dimensionless. Again viscosity coefficient m1 l minus 1 t minus 1 is for x. Then radius is m0 l1 t0 is power y. And pressure gradient, the pressure is m1 l minus 1 t minus 2 and divided by one more l, that is m1 l minus 2 t minus 2 power z. Now it will here m raised power x, l raised power minus x, t raised power minus x. Here will be m raised power 0, l raised power yes y and t raised power 0 multiplied. Then here it is m raised power z, l raised power minus 2z and t raised power minus 2z. Power y is 4 and p by l raised power 1. So this will be some constant k. So v equals to k r raised power 4 upon neta and p by l. Now this is the relation, but since you are given k equals to pi by 8, therefore v will equals to pi by 8 r is power 4 p by neta l. So this is the relation, and now we can see again this rate of flow through pipes is depending on the viscosity coefficient, radius of the pipe and the pressure gradient there. So let V is proportional to neta power x, V is proportional to r power y, and this V is proportional to p by l the power z. This is the pressure gradient. Now required relation will be equal to V equals to some proportionality constant k neta power x, r raised power y and p by l raised power z. Now giving dimensions both sides, we get here the rate of flow, that means volume per second. So m0 l cube t minus 1. Here k is dimensionless, the neta is m1 l minus 1 t minus 1 power x. R is length, that is m raised power 0 l1 t0 power y. It is pressure gradient. So pressure divided by length, that will be m1 l minus 2 t minus 2 raised power z. Now just power are to be multiplied, so m ki power x, l ki power minus x and t ki power minus x. Here the power will become m raised to 0 while l raised power y and t raised to power 0. Here again you have to multiply. So m power z, then l raised power minus 2z and t raised power minus 2z. Then these powers are to be added. So left hand side is m raised power 0, l raised power cube, l raised power 3 and t raised power minus 1 is equal to m raised power x and then z plus. Then l is minus x plus y minus 2z, minus x plus y minus 2z, and t raised power is minus x plus 0 minus 2z, that is minus x minus 2z. So according to principle of the homogeneity, comparing m, these are you are getting 0, then it will x plus z, this will x equal to minus z. Now the l is 3 left hand side, here it is minus x plus y minus 2z. So 3 equal to minus x plus y minus 2z. X can be written as minus z, so minus will become plus z plus y minus 2z. Z minus 2z will become minus z, so it will be y minus z equal to 3. Now we'll just leave it for some time, for instance, and then we'll compare t. So t is minus 1 is equal to minus x minus 2z, minus x minus 2, and x is minus z, so minus 1 plus z, and minus 2z, that is equal to minus z is equal to minus 1, so z is equal to 1. Now since x equal to minus z, so x equal to minus 1, Now putting this value of z over here, so z is equal to 1, so y minus 1 is equal to 3, so 1 comes over here, so y equals to 4. Now we are getting x equal to minus 1, y equals to 4 and z equals to 1. Now the required relation will be v equals to k, neta is power minus 1, r is power 4, py is power 1. So v equals to k, r is power 4, p upon neta l is the relation. Since we are given k equals pi by 8, so we will have one more step. So v equals to pi by 8, r is power 4, p upon neta l. So this is the way how these problems are to be attempted.